Welcome to Life Cycle Talks, a series of talks presenting the research front to keep you up to date with the science and application of the life cycle perspective. Today's Life Cycle Talk will focus on chemical footprints. We will deepen our knowledge and understanding of how to assess chemical risks and explore whether chemical footprints can provide decision support to reduce chemical risks. My name is Julia Liu, and I'm delighted to welcome our guest, Hanna Holmquist, Senior Toxicologist at ChemSec, an NGO driving the change to safe chemicals. A warm welcome to you, Hanna. Before we get started, I'd like to share a few practical details. All Life Cycle Talks will be published and made available on the Swedish Life Cycle Center's YouTube channel. Please note that the raise hand function will not be used for Life Cycle Talks. Please feel free to submit your questions using the Q&A function. We will select a few to address during the Q&A session after Hanna's presentation. Back to you, Hanna. I'm curious about what motivated you to begin exploring this area of research.
Thank you, Julia, and thank you for that question. Well, I'm an ecotoxicologist, and I started out, like many ecotoxicologists, with pollution in the water environment and environmental toxins there. And when we were trying to find out where did they come from, we used often substance flow analysis. And I realized that a systems thinking and a systems perspective is essential. And at that time, I became curious about if life cycle assessment could provide such system thinking and good decision support. So that's where it all started for me.
Thank you. And now it's time for your life cycle talk.
Thank you. And thank you for that kind introduction. So I will talk today with a focus around this question. Can chemical footprints provide decision support to reduce chemical risks? And I would like to start with a question to everybody in the audience. If you can think of any system that can be expected to emit no hazardous substances, and with a focus then on the toxicity related hazards. So if you have a system cradle to grave from raw material outtake through manufacturing, use, end of life, it could be linear as depicted here, but it could of course be circular. In many cases, we can expect emissions of potentially toxic chemicals. If we have metals in these systems, we could have losses of heavy metals from mining. If it's a fossil-based system, we could have losses of petroleum products. If it's a bio-based system, we could have pesticide use. The manufacturing could include losses of ingredients or auxiliary chemicals such as solvents or biocides if these needs to be used in the manufacturing. The use stage, if you have a plastic product, it could lose additives over time. For example, if you have a soft plastic product, you know it goes frail over time. It lost its softener. We could have wear and tear causing the emission of microparticles, for example, from your outdoor garments. And then, of course, we have the down the drain products, a shampoo or a cleaning agent, and it goes straight to the wastewater. In the end of life, we could have unintentionally formed transformation product if we have an incineration process, for example, or the losses of untransformed chemicals, for example, if we have a landfill. So you see, this is not an exhaustive list. And any one system does not necessarily include all these emissions, but it is relevant for many products and services to ask ourselves the questions: could the request for this function generate emissions of potentially toxic substances? And that leads us to this question: what is then a chemical footprint? Could it be the answer? But I need to take a couple of steps back first. As Julia said, I now work for ChemSec. And at ChemSec, we have the Chem score, where we rank the world's top 51 chemicals producers on their work to reduce their chemical footprint. The Chem score, I encourage you to go to chemsec.org and watch the latest Chem score launch. It's a brilliant film. And in the Chem score, that is a score on the chemicals management of the companies, the strategies for chemical management. the transparency, etc. It's quite similar in the chemical footprint project by the Clean Production Action. So you see the chemical footprint as a concept, it can be used in several different contexts. But here, when I talk about it in this talk, I do it in a life cycle assessment context, and I define the chemical footprint as an aggregated indicator of chemical pollution that enables the assessment of the potential ecotoxicological and human toxicological impacts of the entire life cycle of a product or a service. So this is the meaning of chemical footprint herein. And just very briefly, how do we calculate the chemical footprint? Well, we have the same system, cradle to grave, be it linear or circular. Around this system, as in always in LCA, we put a systems border. And anything that crosses this system border, we characterize for its potential impact. When it comes to toxicity impacts, the characterization factor often include considerations of the fate of the chemical, its exposure of humans and the ecosystems, and the effects thereof. So it could be emissions to water, for example, emissions to air, we aggregate those, and we arrive at a potential impact. But I will come back to the system border because it's not as easy as it seems here when we talk about chemical footprints. More about that in a bit. So chemical footprints, or at least toxicity impacts in LCA, it's nothing new. The use-tox model, for example, that is a often used impact assessment model for toxicity, it was launched in 2008, and it wasn't the first one. But it has been a lot of interesting things happening lately, a lot of really relevant results being presented. And this was all captured very nicely in last year's autumn when we had CETAC Europe LCA Symposium, arranged by the Swedish Life Cycle Center here in Gothenburg. And at this conference, I shared a session together with Olivier Jourgier at DTU on chemical footprints, informed decision-making for reduced chemical risks. And I think to answer the question I have in this talk, I can make use of the presentations that we had for that session. And I think they capture the field in a very nice way to date. So we had 5 oral presentations and 2 poster spotlights, and then a number of really good posters as well, of course. To start off, Pernilla Andersson from Chalmers, and she's now with IVL. She presented how to make chemical footprints practical. So she focused on the user needs and drivers. And then Olivier Jourgier, my co-chair, he's from DTU, and he presented risks and impacts of chemicals in consumer products on human health and ecosystems, the extension of use-tox. So use-tox is now available in a version 3, including the consumer product emissions and direct exposures of humans. Then Heather Logan from DTU as well, she presented her PhD project. So it's now available online, and I encourage you to go look there. She talked about adding up the additives. So she makes available approaches and tools to include the plastic additives when you do a plastic-based LCA. And that is key, of course, to make it complete. And then Jutta Hildenbrand from RISE, she spoke about the Mistra SafeChem project and one of the case studies therein on the substitution of cyclic siloxanes in cosmetics, where they integrate chemical footprints in a safe and sustainable by design assessment, which is, of course, key nowadays in the chemical strategy for sustainability. And then finally, Sofia Högstrand from Lund University, she spoke about the applicability of incorporating bioassays in LCA to get a more complete result. So she looked at wastewater, which is very complex, and she could show that when she used a bioassay, she got a much more complete result compared to using only the few direct chemical analysis results available for a few chemicals. And then Anna-Karin Hellström from RISE, she spoke again about the Mistra SafeChem project. So it is still running. At the time of this conference, it was about half term, and she presented the life cycle-based assessment toolbox to assess and improve safety and sustainability of chemicals. And then finally, Sonia Martel-Martin spoke about safe and sustainable by design in practice. And myself, I've been involved in a couple of these projects. So just to give you a bit more of a flavor of the content, I would speak a bit more about the Formas Tox-redUSE project and the Mistra SafeChem project. So first, the Formas Tox-redUSE project on making chemical footprints practicals. So The project is to be finalized this year. It's run by my former colleague Rosella at IVL, and it aims to lower the threshold for the implementation of tools for chemical footprint calculation in industry. So in this project, researchers from IVL and Chalmers cooperate with involved companies in a co-creation process. And it's going to be so interesting to see the results, of course. Already now we have a report available online by Pernilla and colleagues on the landscape. So in that report, the tools available and the drivers to use these tools are mapped up, and we can see what scope they cover and what kind of questions they can answer. So go online and find this report. Important policy drivers include, for example, the Zero Pollution Action Plan. But I will give you some example then. So the mapping of tools include a number of inventory databases and impact assessment models. So this list is not exhaustive. Go visit the report to see the full thing. But on the inventory databases side, we see there are a number of databases, for example, EcoInvent and the EF compliant dataset that includes chemical flows. But we also saw that none of them are explicitly derived to use for chemical footprints. So the user has to be very aware of the expected chemical emissions from the system under study to make sure that the database selected will do the job, or if it needs some complementary actions. Also, on the impact assessment modeling side, there are plenty of models available. For example, the product environmental footprint, ProScale for the workplace-related emissions, at least that's how it started. Recipe, which is a package of impact indicators, and then not the least, UseTox in version 2 and 3. And here it has to be said that some of these models have evolved and make use of results from the other model development, but also they're integrated into one another. So for example, the PEF model builds on UseTox 2. All of that is also explained in this report. So the mapping up of user requirements, what was seen in the project is, for example, that when we include toxicity indicators in LCA, we need to meet across competencies and maybe also in organizations across organizational borders. So the toxicologists and the risk assessors need to work with the sustainability experts. That can be super interesting and also a challenge for the companies. We also learned that the user requirement differs between companies, maybe because of who we talk to, but also how they have set up their chemical management strategies. So for example, while some companies, they want to use the LCA approach really early, and by that use estimation methods to try to estimate chemical properties, etc., to get an early result. Other companies say they are only interested in applying the LCA on very mature system and would never apply in silico methods to describe a chemical because it's way too uncertain. So it will be interesting to see what the project concludes there. And then for Mistra SafeChem, this other project where I've been involved, it's half term, and in the work with the life cycle assessment tools and the life cycle based assessment toolbox that is being developed to support the assessment of the sustainability of chemicals, we have another report available now. So go visit mistrasafechem.se to find this report towards safe and sustainable chemistry. So the starting point is the belief that a transition to a safe, sustainable and green chemical industry requires system thinking and full life cycle integration. And to make this happen, we need rapid screening tools. And in these, the integration of hazard and risk data into life cycle impact assessment. And this is crucial for informed decision, both in process design and in chemical substitution. So in Mistra SafeChem, the UseTox model and the ProScale model have been in focus, and both of these are further developed as part of the program. And a strong focus has been on the use of in silico substance property predictions and the incorporation of these kind of data into the impact assessment modeling to support the need of rapid screening tools. And I promise to come back to this conceptual connection between conventional LCA and the system border and the life cycle based chemical assessment toolbox. So normally we are inside the border in the technosphere and outside the border in the ecosphere. And outside the border, the ecosystem can be exposed to the emission, and also humans via the environment, for example, via our drinking water and via our food. But when we talk about the chemical footprint and the aggregated indicators, we are also interested of emissions inside the technosphere. All of a sudden, the technosphere is also inside our system border. So, for example, we have direct exposure of humans via the consumer product, now captured by use Tox-3, for example. They call it the near field. And then we have also human exposures in the workplace, direct exposures, which is, for example, captured by the ProScale model. So for a complete chemical footprint, when that is relevant, we need to look at both the direct and the indirect exposures. So I'm wrapping up the talk, and I hope that you go and visit the websites of the projects that I've been exposing a bit here. And back to the question then, can chemical footprints provide decision support to reduce chemical risk? My answer is yes. Yes, if we have a strong focus on the usability of the tools. Quite often, as we saw, many systems can be expected to emit potentially toxic substances, but it also needs to be used in a correct way. And that can be challenging because we need to have a transdisciplinary approach. We need to involve both people who understand the toxicity and people who understand the systems approach, right, with the LCA. Yes, with a continued model and method development. We have to keep up with the research in the adjacent fields to get closer to capturing the full picture. I mean, any system could have sometimes several hundreds of flows of chemicals emitted. And it is difficult to capture all of them in an LCA. But if we keep track of the research ongoing, how to populate these flows with data, and when research learns more about the chemicals and what function they provide, we can arrive at a more complete assessment. So we need to keep up with the ongoing method development and research. And then, yes, with appropriate data gap analysis and iterations in the derivation and interpretation of the results. Because, as I said, if we have several hundreds flows, we might have data gaps, and that's completely fine. But if we get to learn more about our system, we can learn what gaps we need to fill and what tools are available to fill this at the moment. And we can also interpret the results in relation to these gaps. So that has to be always remembered. We could have gaps in the inventory, and we could have gaps in the characterization. And then finally, yes, with innovative solutions to capture as of yet uncharacterized flows. And Sofia from Lund University gave such a brilliant example of that, for example, by using bioassays to capture also the effects of those substances that hadn't been measured in the wastewater that she studied. So I think, yes, it's doable, and we should use the LCA approach also to chemical risks. But my final message would be that chemical footprint assessment, it must be complementary to risk assessment. It is not a tool to avoid dealing with chemical risks, just to point at a larger risk somewhere else in your system that is far from you. It is a tool to be more inclusive chemical risks. So deal with the risks in your decision sphere, but make it possible for you to also discover other risks that the product or service in focus give rise to. So with that, I would just like to thank a lot of people who've made all the work that I presented here. Thank you. I worked with you guys in Mistra SafeChem, at IVL, at DTU, etc., and in Formas Tox-redUSE, IVL and Chalmers. And not the least, the industry collaborations in the projects and from my time at IVL and Chalmers. Thank you ever so much.
Thank you, Hanna. Now, please feel free to submit your questions and using the Q&A function. And I have some few questions for you. I will start with my own and then select some from the Q&A. Unfortunately, we don't have time to cover all of them, but I will try my best. So let's start with considering risk assessment are already conducted for the chemical and cited. Isn't there a chemical footprint unnecessary step?
Yeah, I would say if I mean, if we have to start by how does the value chain for a general product look like? It is quite often global. So if we would have appropriate chemical risk assessment globally, then we wouldn't need the chemical footprint. But unfortunately, today it looks very different between different regions in the world. And as long as that is the case, I think the chemical footprint approach is a very good way for us to capture chemical risks that we can, from the point of request here, if we produce a product or if we request a product, we can reduce risks elsewhere if we capture them with a chemical footprint assessment.
Good, thank you. And my second question is, which impact assessment model is recommended for use?
So this is the interesting thing, right? That there are several models available and they all have their strength. So it depends so much on the question you want to have answered in your project. So I wouldn't recommend that you always press, the same button in your LCA software, but rather go to that report by Pernilla and colleagues and see, what answer do you get when you choose one model or the other. And maybe for one certain project, it is the use-tox model that provides a correct answer, and in another, it might be the ProScale or the both of them if you need to capture both the direct and indirect exposures. So I think you have to be very careful in the goal and scope when selecting both the inventory database and the impact assessment model.
So connect to this question, what inventory database is most suitable
Yeah,
to
exactly.
use?
And the answer to that question is again, it's very similar because we saw that the inventory databases available, they differ quite a lot, both in how large they are and what type of flows they include. So it depends on what materials you have in your system and what chemical flows you need to capture. So I think any goal and scope work when you want to do chemical footprint assessment have to start with somewhat of a qualitative LCA, getting to know your system. What materials do you have in there? What chemicals can be expected in that system and what emissions do you need to capture? And in my doctoral research project, I quite often tested out an approach to complement the inventory databases. So they were good, but they were not complete. And then I inventoried additional flows that I added to my system to make sure that my product and its flows were fully captured.
Good, thank you for that. And how significant does the differences in potential impact between life cycle stages need to be to ensure a reasonable level of certainty?
Yeah, I think that is, again, something that I can't give you an exact number on. But as in any LCA, we have to be careful. I mean, if we have the 4 bars, one potential impact for the raw material outtake and one for the manufacturing, etc. If we have a small difference between the life cycle stages or whatever you're comparing, you should be careful to draw any firm conclusions because any LCA builds on a complex system and you're bound to have uncertainties in there. So it's rather large differences to be able to certainly say that you have a difference. But again, see it as a way of mapping up your system. And if you do see a difference, go in and see, well, the data supporting this different, are they robust or do we need to do some more data gathering to be quite certain that this wasn't an uncertainty? So don't draw conclusion too soon. Work quite a lot with your system. That would be the recommendation. And that's not specifically for the toxicity impact, that's for any impact, I believe.
Okay, thanks for that. And here's a long question. One hope with new approach method is to avoid missing chemicals by using the whole effluence approaches. But how do you see the risk that we end up needing many different NAMs to consider oxidative stress, different kinds of hormonal activity and more? Will we end up with too many indicators and lose the aggregation we hope for?
Okay, let's see if I understand this question correctly. So the new approach methods or the NAMs, it's a way to avoid full body chemical testing on animals. And the bioassays, for example, in the example that I gave, she had used a NAM on the estrogenic activity. And of course, depending on what flow we're studying, what system we have, that might not capture the whole thing, of course. Then you might need a battery of NAMs. So the oxidative stress or the estrogenic activity, thyroid effects, etc. And that is bound to be quite complicated, but I think we now also have the power to handle big data. So I think at the moment, the use of bioassays and NAMs in LCA is not straightforward, but I'm sure, and I know there is a lot of ongoing research, so follow that field if you're interested, because the risk assessment field moves towards NAMs, even though it isn't replacing the animal testing. And I mean, this has always been the case, that it is the risk assessment field that generates the data that we use for the toxicity impact assessment in LCA. So when the risk assessment field changes its data generation, the life cycle impact assessment needs to follow. So we need to keep track of that. But yes, there could be a need for very many NAMs to capture the full effect. And those have then to be aggregated maybe into one score.
Thank you for the answer. And the next question is, thank you for a nice presentation. As we include chemical risks at midpoint level, how can we decide the footprint and the risk is high risk? Weighting or approach to relate it to a planetary boundary?
That's also a tricky question. I think the starting point has to be that when we do this in life cycle assessment, we talk about finding out about chemical risk, but it's not a risk assessment in the terms of safety assessment. So when you do this in LCA, you try to find the hotspots. Where do we have the most potential for problem? But we don't say it's safe somewhere and it's not safe somewhere else, because we aggregate over space and time. With that said, to discriminate, is the toxicity impact, are they more important than any other impact? For example, I mean, there are normalization procedures and weighting procedures, for example, built into the PEF system that can be used. We also have a lot of examples where the midpoint results are translated into endpoint results, and we can compare disability adjusted life years across impact categories. So there are ways to do this, but I think we always have to keep in mind it's not a safety assessment when we go into LCA.
Yes, now here's the last question that we can cover today. How are the responses or reflections from Chinese versus European industries? Is there any differences?
Oh, I wouldn't know that actually. So in the projects where I've been involved, it's been Swedish-based industry and European-based industry. And many are very curious about these, and many are used to using LCA for their carbon footprint work, and then they have compliance professionals working with regulatory compliance, and they are curious about how to marry this together. I wouldn't be able to say if it differs in China. I don't know.
Thank you for all the questions submitted through the Q&A, and unfortunately, due to the time constraints, we cannot address them all. So it's wonderful to see such a strong interest in this topic. Thank you, Hanna Holmquist, Senior Toxicologist at SafeChem.
Thank you.
If you are interested in exploring more about how chemical footprints can offer decision support to mitigate chemical risks, I recommend to checking out these selected projects and these publications for further information. And all these links can be found in the event post on lifecyclecenter.se. Please feel free to reach out to Hanna with any questions. Her email address is displayed here. The Life Cycle talks are published by the Innovation Cluster for the Life Cycle Perspective and Swedish Life Cycle Center. The details for the next Life Cycle talk will be announced soon. To ensure you don't miss it, follow us on LinkedIn and subscribe to our newsletters. Thanks for listening.